Assalamualaikum. So we are from group 7. Our topic is high level modulation for free space optical communication system. So our group members is Nurul Nabilah binti Muhammad RODZI, Nur FARHAH ATIQ binti JAAFAR, Muhammad AMIRUL AZIM bin LATEF, AISHA JIBRIL Muhammad, and Nur AMIRAH binti ZAKARIA. Abstracts. Over the last 2 decades, free space optical communication FSO has become more and more interesting as an adjust or alternative to radio frequency communication. This article gives an overview of the challenge a system design has to consider while implementing an FSO system. Detailed discuss of this topic can be found in the special issue of the Radio Engineering Journal. So for the introduction, free space optical communication FSO system in space and inside the atmosphere have developed in response to a growing need for high speed and top-proof communication system. The link involve satellites, deep space probes, ground station, unmanned aerial vehicle UAV, high altitude platform HAP, aircraft and other nomadic communication partner are of practical interest. So moreover, all links can be used in both military and civilian contexts. While fixed FSO links between buildings have long been established and today from a separate commercial product segment in local metropolitan area networks, the mobile and long-range application of this technology are aggravated by extreme requirement for pointing and tracking accuracy because of the small optical beam divergence involved. In this article, an overview of the challenge a system design has to respond when implementing an FSO system is provided. So from the transmitter through the medium to the receiver are introduced in this article. Some results concerning the qualitative parameters of the links and statistical characteristic of the atmosphere are described.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, sir. My name is AISHA JIBRIL Muhammad from S11. So from our group, I will be discussing on the methodology. So the principal goal of is free space optical communication device embodies accomplishment, high-speed information transmitting, enabling wireless conversation through free space, supplying last-mile connectivity, organizing dependable and impressive communication, presenting an affordable deployment alternative, facilitating interconnectivity in a difficult environments, and serving as a redundancy or backup verbal exchange system. So in this figure here, we can see how the process is being done. So from the beginning, there is the pulse generator and the optical source, which is connected to the optical modulator, and then optical amplifier, which is connected to the switching. This whole connection here is the transmitting section. From there, we have the wireless channel, which travels through and goes to the receiver. From the receiver, we have the optical amplifier, which goes to the photo detector and then travels through the low-pass filter, which arrives at the ER analyzer. So this process is known as the receiving process. So for high modulation is the imperative in FSO structure for several reasons. Firstly, it enhances fact rate, normally by transmitting a couple of bits per symbol. Secondly, it improves spectrum, making it great to use of the reachable frequency spectrum. Thirdly, high-level modulation brings about robustness to noise and interference, providing specifically reasons useful in atmospheric conditions. However, it ensures the standard goal used to resource, making FSO science extra cost efficient. Compatibility with superior error correction. encoding schemes, and then the adaptability linked to the persistence in the condition.
For the result and discussion is the comparison between different design FSO, which is MIMO, DWM, and DMIMO FSO, and the different distance range. Okay, for the first system design is MIMO FSO. This design using 4x4, meaning the has 4 receiver and 4 transmitter. Okay, then the bit sequence will change the signal into binary and to easy to transmit, and going to pulse generator to carry the wave, and the modulator is to combine the carry and the modulation signal. This function for is to make sure output signal generates same signal output from the previous. So then we use low pass to allow the signal, low frequency signal to pass through, and we use two visualizer, which is eye diagram and optical power. So this is for first circuit 1 km, and the result for Q factor and the optical voltmeter came for 5 km. As we can see, the difference between the first circuit for 1 km, the signal in the graph is more sharp compared to 5 km.
Okay, this is the WDM MIMO FSO system. For 1 km, you can see for the Q factor is high and the system is good. For the minimum bit error rate is low, and the receiver power is 7.305, and for the system it quite good. This one is for 5 km. That is for 5 km. The max factor for 5 km 2.85, and the minimum bit error rate is 0.02. And for the data, we can see that the relationship between wavelength and the signal power indicate that when the wavelength decrease, the signal power also decrease. Okay, that's all for me.
This is circuit for the MIMO system. So the MIMO system is slightly same with the MIMO system. This circuit just add the other one of mesh xender modulator. So it use same components such as a port which duplicate the number of output ports, so that all of the signal from the component may be linked to the other component, can run for 1 km. This is result for 1 km for the MIMO system. So we get the maximum Q factor is 116.157, and the minimum of bit error rate is 0. For the power output is negative 7.483 dPm. So for the 5 km, this is the result of 5 km range. So we get the maximum Q factor is 5.10285, and the minimum bit error rate is 1.67198 E negative 7. So for the power output power is negative 21.854. For range 5 km is get lower than 1 km. Okay, based on the result discussion, we can conclude that comparison between FSO system in difference range, MIMO FSO consistently the highest Q factor and have a good signal quality with low error rate both 1 km and 5 km.
Similarities of multiple phenomenon free space, optical variable exchange system, WDM, MIMO, and then DMIMO. The goal was to evaluate their goal performance, improvements in terms of sign energy levels and satisfaction factor, Q factor. In heavy weather condition, the results shows that the proposed DMIMO FSO device outperformed the other three systems significantly. Also, additionally, the WDM approaches in the MIMO increases system capacity by means of permitting a couple of in particular records seems to be transmitted on extraordinarily wavelengths simultaneously. This provides another layer of multiplexing gains compared to MIMO techniques alone. The aggregates of WDM and MIMO in the D-MIMO gadgets give higher of crosstalks, more suitable bandwidth, and evaluate signals to noise performance. Thank you.